Hey everybody, let's focus on principal axes and principal moments of inertia. So I'm just going to use the example out of the book since it already sorted out the answers for us, so that way I can just focus on the explanation. So let me start by sketching that triangle. So I'm picking a plane, and then a sketch, and then I'm just going to sketch a triangle. Okay, there we go, triangle. And right now, nothing is constrained, nothing is dimensioned. So let me dimension the side. So right click brings up this selection wheel, sketch, next selection wheel, dimension. So I'll make this 4 meters. Okay, 4 meters. This document happens to be in feet right now, so let me just change this over here. Change this to meters. Okay, so now if I dimension here, the default unit is meters. So if you just type 3, it's 3 meters, or you just explicitly type M for meters. Okay, so I got the sides. See how I need this side. I'm holding control on this side, so I pick those two sides. These need to be perpendicular because it's a right triangle. So up here in constraints, you see perpendicular. Okay, so that, see this little icon right here? That's the perpendicular constraint. And now I want this corner to be here, coincident with the origin. So see, this coincident is because there's this line and this line, but now I'm going to take this point and put it coincident with the origin, and now a new constraint pops up saying, okay, that corner is coincident with the origin. And now I can still do this. I'm just going to make this horizontal, so this constraint up here, horizontal, and now see all the lines. Let me do that again. Right? See how they're blue? The lines, the sketch lines. But if I make this constraint to be horizontal, all the sketch lines turn black, which means now the sketch is completely defined. Right, so let me finish. And now let's turn this into a solid. So like that. And here we go. That is not a thin plate. Let's make it a thin plate. So let me go back here, edit feature, and I'm gonna type what I want. I'm gonna make it like really ridiculously, like a micron thick. Okay, so here's what we got. It's a ridiculously thin plate. All right, now if you go here, this is the body that got created. I'm just going to name it plate. Okay, triangular plate. If we right click, go to properties, it shows us the area. This is the total surface area, meaning the front, back, sides, everything. The density looks like this is steel, which was the default material. So we know the mass, the volume, and the location of the center of mass with respect to the origin, which is what we expect. 1/3 of the way over 4 meters, 1/3 of the way up 3 meters. And here, this is the moment of inertia with respect to this XY coordinate system. Okay, so let's compare to the answers. So in the book, this is the area moment of inertia. So for example, 9 meters to the 4th. If we want the mass moment of inertia for a thin plate, let me bring my calculator. So then it will be 9 times the mass, 0.047, divided by the area of the shape, which is 1/2 base times height, which is 6. Okay, so here 0.071, and look over here, 0.071. Iy would be 48 times the mass, 0.047, divided by the area, 6, 0.376, over here, 0.377, very close. Okay, and the product of inertia, Ixy, is non-zero. See right here, it's non-zero. Now, if we rotate the coordinates by 21.4 degrees, then Ix, according to the new coordinate system, will become a minimum at 1.96. Iy will become a maximum, 55, and the product of inertia should go away and become 0. So we'll see this go to 0. Okay, just to make computations easier, I'm going to change the density of this plate. So, physical material. Sounds weird, but I'm going to make it water, because I know the density of water is around 1,000. So let's go to the properties one more time. See the density, 998. So now, if I had to do 9, if Ix is 9 times the mass, 0.006, over the area, 6, then it's just a factor of 1,000, right? So 9 meters to the fourth is 0.009 kilogram meter squared. 48 meters to the fourth area, 0.048 kilogram meter squared, right? So makes it 18 meters to the fourth product of inertia minus 0.018 kilogram meter squared. Okay, so now let's rotate the coordinates by 21.4 degrees counterclockwise, which is equivalent to just rotating the part clockwise and leaving the coordinates as they are. So let me do that. Okay, so back to our sketch. I don't want this constraint where it's horizontal. Right, so now you can move around like this. So I want my new coordinates rotated by 21.4 degrees. So rotating the coordinates counterclockwise is like rotating the part clockwise. Okay, so, and I want it to be with respect to the horizontal. So I'm actually going to sketch a horizontal line. And I'll turn this into a construction line right here. So see how it turned into a dashed line? And now I'm going to use that to dimension like this. Okay, and then what we were looking for, 21.4. Okay, so allegedly, if we look at the properties, we're expecting to see Ix be 1.96, well, divided by 1,000. Iy is going to be 55, so 0.055. And the product of inertia should be 0. Okay. Alright, so that's what we expected. Ix 0.002, Iy 0.055, product of inertia Ixy 4 times 10 to the negative 5, practically 0. That seems to be just round off error. Let's try and do a little bit better. So okay, let me bring my calculator actually here. So I think it just was this round off error in computing the angle. So it's supposed to be here, tangent 2 times 18, 36, over 48 minus 9, 39. Okay, take the arc tangent of that, and then divide it by 2. Okay, so with more precision, 21.3 0.35. I'm just going to copy this entire thing and then paste it here. Okay, so the angle, I have all those decimal places of precision for the angle now. So now I'm more confident the product of inertia is going to be closer to 0. So let's check it out. There we go. That's better, right? Now the product of inertia is 0. Okay, so notice Ix 0.002, Iy 0.055. If I were to rotate the coordinates another 90 degrees, those two numbers will just trade places. Ix will be 0.055, Iy will be 0.002. So let me do that right now. So here I'm just going to add 90. Okay. Here. So now what we're expecting is Ix will be 0.055, Iy will be 0.002 here, and the product of inertia still 0. Okay, so give this a try. I can explain more. If you have questions, just let me know in the forum, and I'll see you on the next video.